Okay, students, let's get started on the second part of the instructional video for solving equations, trig equations, and what we're going to focus on now is the factoring aspect. So most of these problems we're going to look at have something to do with factoring in them. So first thing we're going to look at is, let's look at these examples. Again, you're solving on an interval. So when you see this, that means you're going to be in radian mode. You're going to give radian answers, and we're going to give specific answers on an interval, unlike solving and getting a formula like we did previously on some problems. All right, so generally the first thing you're going to look for is, you want one side equals 0. So that is the case on all these problems. If you don't have that, and it looks like factoring is a part of the problem, you want to make sure that one side is equal to 0. And then the second thing you generally do is going to factor. So all these basic examples are going to have factoring involved in them then. All right, so if you look at this first example, this has a common factor of a sine x. So you're going to pull that common factor of sine x out, and then you'll have a parenthesis. And what you're left with here is secant x minus 2. Anytime you factor something, you should distribute and check and make sure it's right. So that's sine times secant and sine times 2. So that's right. Okay, next thing you do is you want to set each factor equal to 0, because you're going to try to determine what makes the sine 0 and what makes the secant of x minus 2 equals 0, and you'll see if you can reason these out with the unit circle. All right, so I'll pull up the unit circle over here, and that will be a big part of what we're going to be doing in this section is working with those two things then. All right, so let's kind of go through and let's see what we have. The sine is equal to 0. The only place on the interval 0 to 2 pi where the sine reaches a value of 0 is at 0 radians. Okay, so that's going to give one solution to this problem is going to be 0 radians. Okay, that's the only place that, hold on, teacher. The other place it happens is at pi radians, okay? All right, because it's a y value, all right? So I almost caught myself on that, making a mistake. So, all right, those are the two places where the sine is 0 in one lap around the circle. All right, now what I'm going to do is add 2 to both sides, so I can just move the 2 over here. I will get secant of x equals 2. Now, generally, I think it's easier to work with a cosine than it is a secant. So remember, the secant, the cosine's 1 over the secant. So we can write this as cosine x equals 1 over 2. Okay, then we'll look at where the cosine is 1/2. The cosine is the x value on a unit circle. So what's going to happen in these two locations? So in radians, that will be pi over 3 and 5 pi over 3. Okay, so that'll give us the other two answers that we have. All right, so we'll have that then as our answers. And when we put this all together then, the solution to this problem is then going to be, and it doesn't matter what order, I'm just going to say 0, pi over 3, pi, and 5 pi over 3 will be the specific radian answers to that problem then. All right, so that would be how you would write that in a solution set like that. Now I'm going to pause here just for a minute and set up the calculator, and I'm going to check on some of these things with the calculator. So I'm going to pause here and show you how I'd set that up. Okay, so I just wanted to pull up my calculator, and I'll show you how to put this in. What I would do on this one is just do the left-hand side of this. Now, a secant is 1 over cosine. So one thing you could do is you could put this in like this. You can put the secant in as 1 over cosine of x. Okay, like that. And then we would have times the sine of x. Okay, like that. And then we'd have minus 2 sine of x like that. So that's how you could put this in your graphing calculator, is like that. And as far as the mode, okay, we want to be in radian mode. So I want to get in radian mode. For the window, I'm going to do standard. We're solving from 0 to 2 pi. So I put in 0 to 2 pi, scale by whatever you want. Y, it's probably okay to go -2 to 2 on this, or you might want to go a little bit bigger. It doesn't make that much difference for what we're going to do. I'm going to expand this out and maybe make this -4 to 4 and work with that viewing window then. Okay. All right, so what I'm going to do is I graph this, and then again what I can do is just trace out my solutions. This shows that we have 4 solutions, so we should be crossing the x-axis. It looks like 4 times in here, so I'm going to show you that. I'm going to bring my graph over here and just label a couple of things on here as I go through this. But what I mainly want to do on here is just trace these answers. So our answers are 0. Okay, so if I trace at 0, okay, that's given an answer of y equals 0, so that's good. If I trace at pi over 3, okay, that'll trace out the second solution and verify that. If I trace at pi, that verifies that solution. And then I got 5 pi over 3, so I do 5 pi over 3, and then that will do that. It looks like 2 pi is also a solution, so if I traced at 2 pi, then I'd also have a, whoops, okay, that's out of range though, so I think I may have put that in wrong there. That's ending up being out of range on that when you do that, and you're actually, that secant is undefined there, so that doesn't count as a solution. And actually, we weren't even paying attention to 2 pi either. The thing I want to show you is the reason why an error comes out when I trace at 2 pi is because the secant is undefined at 2 pi. Okay, like that. Hold on, that's not right. So I think my window is just not set up on that right, but it doesn't matter because we're not paying attention to 2 pi anyway. All right. You would have some places where you'd be undefined. The secant would be undefined at pi over 2 and 3 pi over 2. So basically it doesn't matter on that. It's because of I think the way that window was set up is why that's incorrect then. Okay. All right, so let's see. So that'll take care of that. That graphing will verify that we've got all those answers correct then. All right, so the rest of them, let's just go through and do this. I'm not going to verify all of them on the graphing calculator, but I do want to do some of these. Okay, so the next problem we're going to look at is one side is set equal to 0, so you're always looking for that. And in this case, how do you factor something like this? Does this have a common factor? Yeah, the cosine is a common factor, so you'd bring out a cosine, and that would leave you with cosine of x minus 1 equals 0. Again, double check, distribute to make sure it's right. Cosine times cosine is cosine squared. Cosine times 1 is cosine. Then it's a matter of setting each individual factor equal to 0 using the unit circle to solve. So we're going to solve cosine x equals 0. Then we're going to solve cosine x minus 1 equals 0 to get our solution. So if we look at the unit circle, let's think about, okay, where is a cosine 0? A cosine is an x value, so the x value turns out to be 0 at pi over 2 and 3 pi over 2. So the angular answers in radians are going to be pi over 2 and 3 pi over 2. Okay, the next part, you would want to add 1 to both sides, and then what you're looking at is where is the cosine 1? The cosine turns out to be 1 only one place on the unit circle. That's the only place where the x value is 1, and that happens at 0 radians. So when we put the solution together, we would have 0, pi over 2, and 3 pi over 2. Again, we would not count 2 pi. 2 pi is another answer, but that's not within our interval because our interval said exclude the 2 pi. So the answer to that problem would be 0 pi over 2, 3 pi over 2, like that. Okay, that would be the idea. All right, so that's how you do those. The rest of them are going to be factoring. The next two are really trinomials. So I'm going to go through and we're going to factor these. Okay, whoops. So what we want to do on this is just factor the trinomial. So this one kind of goes like this. It's reverse FOIL. So it really goes kind of like this. You would draw out 2 parentheses, and the first term would go here and here. That would have to be sine x times sine x in order to get a sine squared x. Okay, the last term is a 2, and that will go here. The only possibilities are a 2 and a 1 to do that. So you're doing a trinomial, except you're using a sine instead of x. This is exactly the same concept as factoring something like this. Okay, so now we've got to figure out the sign. So if you look at this inner term is 2 sine x. This outer term is 1 sine x. And what you're trying to do is you're trying to make this add up to positive 1 sine x. So the way you make 2 and 1 add up to positive 1 is to have a positive there and a minus there. 2 minus 1 would be 1. So that means you get a plus sign there and you get a minus sign there. So every time you factor something, again, multiply it out at least in your head to make sure you're correct then. Okay? Then, same process, you're going to set each individual factor equal to 0 and solve. So we need to solve the equation sine x plus 2 equals 0. And we also need to solve the equation sine x minus 1 is equal to 0. Okay, like that. All right, then we'll solve these two equations. So the concept is, again, subtract 2 from both sides. You would have sine x equals negative 2. Now you would have to look on the unit circle, and the question would be, does the y value on the unit circle ever equal negative 2? Well, clearly it doesn't. If you look at your y value, the biggest y value is 1. The smallest is negative 2. So this is undefined, so you get no solution out of that. There's no place on the unit circle where the sign takes on the value of negative 2. So you can just you get nothing out of that factor. If you move on to the next factor and add 1 to both sides, you'll get sine x equals 1. Now if you look at the unit circle, remember the sign is the y value, so you got to ask yourself the question, where is the y value 1? The only place happens at pi over 2. All right, so what you would get as your answer to this problem is you would only get the answer pi over 2. That would be your final answer to that problem, would be pi over 2. Okay, that's it. Now this one's probably worth graphing. I think I'll do this one and just one more on here. So if you wanted to do a graphical check on this problem, the way you would do this is like this. You would put in your calculator. If you want to do this with me, you're more than welcome to do this, or you can just watch. So I'd do sine squared like that. Then I would put in plus sine x. Okay, like that. Whoops, got to put the x in. So I put plus sine x and then minus 2. Now I'm going to graph that in the same window I did on the last problem. And we're going to look at the x-intercept. So I've got the same window as I had on the last problem. Now, since we only got one answer, pi over 2, it really should only touch the x-axis in that one place. So if you look at this, it happens here. So if I was to trace at our answer pi over 2, then out pops a 0. Okay, so that's why it's the right answer, is because of that. So you can check that graphically and make sense out of what that problem is saying. Okay? All right, so that's the idea. Checks at pi over 2. All right, so it's worth doing that. All right, let's do one more. This one also involves factoring. So again, we have a trinomial. First term is 3 cosine squared x. Last term's 2. Outer and inner have to add up to negative 2 cosine x. So you just start by drawing your two parentheses. The first term is going to go here and here. So the only possibility is 3 cosine x times cosine x. Can't be anything else. The other possibility for the last term is 2 and 1. So you're either going to go 2 and 1 or backwards. Let's try 2 and 1 that way and see if it works. So again, I would recommend just look at that inner term. That inner term is 2 cosine x. Look at the outer term. That outer term is 3 cosine x. And you're wanting that to add up to the middle term, negative 2 cosine x. So can you make that happen? Yeah, you can have a plus 2 minus 3. Okay, so that means you're going to have plus there, minus there. That's the correct factoring on that. All right, make sure that you just kind of do that by trial and error. Put in the first terms and the last terms and see if you can make the middle term come together from the outer and inner. Then what you're going to do is set each factor equal to 0, like we've been doing. So you want to work on solving 3 cosine x plus 2 equals 0. Then you want to work on cosine x minus 1 equals 0 like that. Okay? And then we're going to look at how we would solve those. Okay, the teacher was doing, and after further review, this was real smart. 2 minus 3 doesn't add up to negative 2 cosine x. I was seeing that I was going to have to use a calculator on this, so I knew I made a mistake. So that doesn't work. All right, so what we're going to do on this is it doesn't factor that way, so we're going to change the 2 and 1 the other way. So sometimes you just have to kind of trial and error this. I do crazy mistakes like that sometimes. It just seems like no matter how careful I am, I make things like that sometimes. So let's see. Let's try the, I don't think we're going to get anywhere with this one. So we have 3 cosine and cosine. We tried 2 and 1. We could try 1 and 2 this way. I don't think we're going to get anything out of this problem this way. It may not factor, so I may have given a problem I didn't intend to even give on this. So that would be 1 cosine. And then this would be 6 cosine. And there's no way you're going to get a negative 2 cosine x out of that. So this is probably going to be a quadratic formula kind of thing, and I'm not really ready to show that to you yet. So I'm going to pause and I'm going to do something here, just and then I'll probably change the problem on this. Okay, so I made this determination. I'm going to change the problem to this instead. I really wasn't intending on getting into the quadratic formula yet. I am going to do that later in the problem. So let's just do this problem instead. I may have typed something wrong on this when I was preparing the notes. So let's do this problem instead. Now when you factor this one will factor in a way that we can solve the problem. So you would have 3 cosine x here and cosine x here to get the first term. And then you could either do 2 and 2 or you could do 4 and 1. So I think it's the 4 and 1 that works on this one if you do this. So I'm going to put a 4 and 1 there. And let's see, that inner term is going to be 4 cosine x. Outer term will be 3 cosine x. And we're trying to make it add up to the middle term, negative cosine x, which happens. So if you have a minus and a plus, you'll get that middle term right there. So what I'll have then is I'll have a minus 4 here, and then I'll have a plus there. Okay, so now the factoring is correct. And then what we'll do on this is we'll do this. We'll set each factor equal to 0, solve each equation separately. And we're still kind of making problems that are designed to be interpreted by the unit circle. This one you would add 4 to both sides. So you would get 3 cosine x is 4. You would divide by 3. So you would get cosine x equals 4 over 3. Okay, that's no solution. Right? There's no place on the unit circle where the cosine's 4/3. See, 4/3 is bigger than 1, and 1 is the biggest x value that you hit on the unit circle. So like the last problem, one of the factors didn't give you a solution. Okay. However, this one, you can subtract 1 from both sides. You get cosine of x is negative 1. So that happens at pi. So that means the answer to this problem, the only answer, would be pi. And that would check out on a graphing calculator. That would be your solution. Okay, so I just wanted to show you real quick the checking on this also. So I went ahead and just graphed on this 3 cosine squared x minus cosine x minus 4. And I graphed that in the same window I've been using. You can see this thing happens at pi. The only time when it's equal to 0, then the y value is equal to 0 is that. So again, you could trace at pi real quick and verify that you have a right answer. Okay. So again, it's always worth looking at those kind of things and checking and verifying. Okay, so let's see. I'll have you go to the next page and basically just work out these three problems. So I'll give you a little bit of time to do that. I'll pause, and when you resume, I'll have them all worked out, and you can check and see if you're on the right track. Okay, so I'm going to have you check. There's a problem with C. I wasn't paying attention when I wrote down my notes, and some of these things had quadratic formula in it, and I didn't want to do this until a little bit later in the notes. So you can check your answers to the first two, and then change this problem to 2 cosine squared x minus cosine x minus 1 equals 0, and then I'll pause, and then I'll let you check that in just a minute, okay? Okay, so you can go ahead and check and see if you did these okay. The key is factoring, and I'm just going to close off this video after this, and I'm going to do a separate video for the third type of equation. So this one, you should have factored a tangent out. You'd have tangent x sine x plus 1, set each factor to 0, and then when you get tan x equals 0, that happens at 0 and pi, and the reason is because of y over x. So notice on this, if you do the tangent of 0 radians, you get 0 over 1, so you get 0. Same thing happens at tangent of pi. So if you do the tangent of pi, y over x is 0 over negative 1, so you get 0. So you'd have those two answers. And then when you set this factor equals 0, you would have sine x is negative 1. The only place that happens is there. Okay, so you'd have 3 pi over 2 pi and 0 would be your solutions to that problem. Second one, I factor a cosine out. This would be your factoring. Cosine x equals 0. Cosine x minus 1 equals 0. So cosine of x equals 0. Two places at pi over 2 and 3 pi over 2. Okay, because it's the x value. Cosine x equals 1, that only happens at 0. Okay, so if you get your factoring done, you'll be fine with these problems, I think. The next one, let's see, the original problem I gave you a tangent, fact it has complex number solutions, so that's not even intended. Our book kind of has things in kind of a crazy order. It's just everything's all mixed up together. I'm trying to increment this and do one thing at a time, so this is a little better problem for now. So the factoring, you would have 2 cosine x plus 1, 2 cosine, and cosine x minus 1. And then set each factor to 0. You end up with cosine x is negative 1/2. That happens these places, 4 pi over 3, and up here at 2 pi over 3. And cosine x equals 1 would only be at 0. Okay, so those would be the answers on that. I apologize for the typo mistakes on that. We will get into how to handle those kind of cases in the next part of this section, though. So this will be a short video, and I'm going to go ahead and close this and post this.